Avogadro's number is yet again another conversion factor, which allows you to go from particles, atoms, molecules, and formula units all to moles. Avogadro's number specifically is 6.022 times 10 to the 23rd. That number goes with particles, atoms, molecules, and formula units, and it all equals 1 mole. Here's a tip for you. Whenever you see the words particles, atoms, molecules, or formula units, that is your clue to use Avogadro's number as a conversion factor. How many atoms are in 1.5 moles of CO2 or carbon dioxide? As always, identify your given and what you're finding. Our given is 1.5 moles of CO2. We're finding atoms of CO2. So your plan is just going from moles to atoms. Keyword, atoms. So we know we're going to use Avogadro's number as our conversion factor. Always starting with your given on top, aligning your units across so they can cancel, and we'll place Avogadro's number on top to get that atoms. Multiply straight across, and you get 9.033 times 10 to the 23rd atoms of CO2. But we have to round because our sig figs tell us from our given there's only 2 sig figs. Rounding to 2 sig figs, you get 9.0 times 10 to the 23rd atoms of CO2. The next example goes from formula units to moles. How many moles are in 7.2 times 10 to the 10th formula units of NaCl or sodium chloride? As always, figuring out what you're given and what you're finding. So we're given the 7.2 times 10 to the 10th formula units, and we're just going to moles of NaCl. Your plan is going from your given unit of formula units to moles. Key word here, formula units. We know we're using Avogadro's number as our conversion factor. Your setup, starting with your given on top, aligning those units across from each other so they can cancel. And this time Avogadro's number is on the bottom just so we can cancel out those formula units. Divide these two numbers and you get 1.1956 times 10 to the negative 13th moles. But we have to round up since our sig figs are only 2 sig figs from the given. Our answer then is 1.2 times 10 to the negative 13th moles of NaCl.